Today we're going to be talking about Z-score percentiles. Our objective is that we will use the standard normal probability table to determine the probabilities and percentiles based on Z-scores. So, first thing we're going to talk about is the empirical rule. And it utilizes the percentages 68, 95, 99.7. What this is telling you is 68% of the data is within plus or minus 1 standard deviation of the mean. So if the mean's here in the middle of our normal curve, here's positive 1 standard deviation, here's negative 1 standard deviation. From there to there, you have 68%. If we wanted to break that down further, we could say from the mean to positive 1 standard deviation, there's 34%, and from the mean to negative 1 standard deviation, there's 34%. So 34 is half of 68. 95% of the data is within plus or minus 2 standard deviations of the mean. So from positive 2 standard deviations to negative 2 standard deviations. So from there to there, that's got 95% of your data. So if there's 68% in the middle and 95 overall between negative 2 standard deviations and positive 2 standard deviations, that means that there's 27% left over, which if we cut that in half, that means each of these smaller sections have 13.5%. Now, 99.7% of the data is within plus or minus 3%, 3 standard deviations of the mean. So from positive 3 standard deviations down to negative 3 standard deviations, that has 99.7% of the data. So between what's left between negative 3 and negative 2 standard deviations and positive 2 and positive 3 standard deviations is 4.7%, and if we cut that in half, that means each of these small spaces has 2.35%. And then we're only left with 0.3% for these outsides, meaning each one is 0.15%. So, the lifespan of turtles in a particular zoo are normally distributed. The average turtle lives 91 years with a standard deviation of 21.4 years. So that means this is 91, and we're going to add 21.4 to go up and subtract 21.4 to go down. So going up, we would get 112.4, 133.8, and 155.2. Going down, we'd have 69.6, 48.2, and 26.8. So shade the regions under the curve for turtles living longer than 48.2 years. So from here, I'm going to shade everything under the curve going to the right because we want the ones that live longer, and that's where our numbers are going up. Now, what percentage of turtles? So this is 2 standard deviations below. So from 2 standard deviations below to 2 standard deviations above, we know that's 95%. Then we said this small one is 2.35%, and this small one is 0.15%. So if we add those up, get that it's 97.5%. Suppose we look at the scores for one component of the SAT. If 45,000 students took the exam with a mean of 528 and a standard deviation of 87, so we're going to add 87 as we go up, subtract 87 as we go down. So as we would go up, we'd get 615, 702, 789, and as we subtract, we'd have 441, 354, and 267. So how can we determine what percentile a student who scored 680 ranked? So 680 was not exactly one of our standard deviations, somewhere in between 1 standard deviation and 2 standard deviations. So what we're going to do is we're going to use our z-score from last class. So remember, z equals x minus mu over sigma. So we'd have 680 minus 528 divided by 87. And if we round to 2 decimal places, we would get 1.75. So it's 1.75 standard deviations above the mean. What we're going to do is we're going to use our normal distribution chart. So we're looking for 1.75 on the chart. So right now we're on the negative side, and I'm going to flip, go to where the numbers are positive. So I'm going to look for 1.7 on the left, and then this is my 0.05 column right here. So that meets at 0.9599, which that means there's 95.99% below, which is what a percentile means. So we have 95.99%, which we would say is the 96th percentile. So what percent of students scored between a 480 and a 760? The first thing we need to do is find the z-score for each of these. I'm going to do the 760 first just because it's the bigger number. 760 minus 528 over 87. That gives me 2.67. Then 480 minus 528 over 87. That gives me negative 0.55. So I'm going to look up both these numbers on my chart. So 2.67. This is the 0.07. 2.6. would be 99.62. And then I'm going to find negative 0.55. So negative 0.055, which is 29.12%. And since I want the space between them, I'm going to subtract them, and I get 70.5%. How many students scored better than a 675? So there's two things in here. We're doing how many students and we're doing better. We're looking at better than a 675. So the first thing we still need to do is find the z-score for 675. So 675 minus 528 over 87, which gives me a z-score of 1.69. So I'm going to look that up on my chart. Go back to the positive numbers. 1.6 and then 9 I lose at the end. 0.69, which is 95.45%. But that table gives us the percentage below. So we're going to have to do 100 minus 95.45 to get the percentage above, which would be 4.55%. However, this wants to know how many students. The total students was 4,000 or 45,000. We need to multiply that by 4.55%, which as a decimal is 0.0455. When we multiply those, we get 2,047.5. Well, you can't have half a student, so we're going to round up to 2,048 students. What score is in the 68th percentile? So this is actually asking us to go backwards. So 68th percentile would be 0.68. So on my z-score table, I'm looking for somewhere inside the chart that it basically says 0.68. And I like this box right here. It's the closest thing to 0.68. And that has a z-score of 0.47. So I know that z equals 0.47. So x minus 528 over 87. I'm going to multiply both sides by 87. So I get that 40.89 equals x minus 528. Add 528 to both sides. I'm going to get that x equals 568.89, except since the SATs don't do decimals for their scoring system and they always round to the nearest whole number, we would say that their score is a 569. That's all for today. I'll see you in class.